In this next section, we'll go through vector operations. So in the exercise you just completed, you normalized a vector to create a unit vector. So given the vector 4, 1, you computed its length, which is the square root of 17, and then you created the corresponding unit vector by dividing each component by its length. And you saw when you visualized this that the normalized or unit vector lay in the same direction as the original vector, but had a different length. So it was length 1. So you've actually already seen the first vector operation we're going to talk about, which is scalar multiplication. So given some vector x, you can multiply it by a scalar. A scalar means a single number. So in this case, we want to multiply by a scalar 2, and that means we're going to multiply each component of the vector by that scalar. And you just did this because you just essentially multiplied by 1 over the length. And so, as you've already seen, scalar multiplication changes the length of the resulting vector, but it doesn't change the direction. A second key vector operation is vector addition. So let's say we have two vectors, x and y, and we want to add them together to get vector z. So when we add vectors, we're adding the corresponding components of the vectors. So we first add the first components together, 2 plus negative 1, to get 1. And then we add 1 plus 2 to get 3. And we can plot this new vector z on our same coordinate system. So that's kind of a numerical way of adding vectors. To think about it geometrically, you are stacking vectors tail to tip. And what I mean by that is you first go along vector x, and then if you want to add vector y, you're essentially going along a vector equivalent in length and direction to y, but where its base is now at the tip of the original vector. So you're going up this arrow y, which is the same, it's just got a different base. And because this is symmetric, we could first go up y and then stack x on top of that and get to our added vector. You can also think of the addition of two vectors as finding the fourth vertice of a parallelogram, where the other three vertices are the origin and the tips of the two vectors. And you'll see that in the next demo. So this brings us to a very important concept in linear algebra, which is that of linear combination. And all that means is that if we have several vectors, let's say v1, v2 through vn, those are a bunch of different vectors, we can multiply each by some scalar, c1, c2 through cn, and then we can add all of that together to create a new vector. So this new vector u, we can call it a linear combination of the vectors v1 through vn with weights c1 through cn, and those are the scalars being multiplied. So in this next exercise, we want you to further develop your geometrical intuition for how scalar multiplication and vector addition work. So you'll play with an interactive demo where you are changing those weights on a linear combination of two vectors. And I want you to think about where you can get to in 2D space. Basically, what that linear combination vector u can be.